Hello there. Today we are going to look at how we can use numbers in exponential form, numbers that really we are already familiar with and already know how to work with. But we're going to look at how we can do this in a little bit more creative way, and in many instances, an actually a lot more efficient way using exponents. So this can get a little tricky. What we have to do is take numbers that we already recognize in the form that they're in, and we have to turn them into some kind of power. That means a value with the base and an exponent. So what you guys need right now is you need a piece of paper. Everybody get out a lined piece of paper and let's get ready to format this, and then I'll go through a couple practice problems with you. All right, I've got my piece of paper in front of me. I'm going to take this paper and I'm going to fold it so that I get one fold right along the middle. So do this however makes sense to you, but I'm going to turn my paper sideways so you can see it. Just going to fold straight across there. One fold that way. And then I'll open this back up. And some people like to just to differentiate where all their work goes. Some people like to, and I'm not going to go all the way up there. I'm just going to start where these lines are, and I'm going to trace that fold down so that I can see it. So I've got that one line differentiating two columns there. I'm going to put the title up here. The title of this is Calculating with Exponents. And you know, now that I've written that and I'm saying that out loud, I actually like, this would be more alliteration, it sounds better, but I'm going to add in parentheses up here that when I say calculating, I really do mean evaluating in part, okay? Evaluating with exponents sounds even better. I should rename this. All right, but here's what I'm going to do to finish setting up, okay? So I'm going to draw a line across this top here, right underneath the title. And then I'm going to skip two lines. And I have what's called college ruled paper here. You might have wide ruled, so your lines might not be as close together as mine. You might not have as many, but it's fine. You should still be able to fit it. So I'm going to skip two lines and draw another line here. So instead of a bunch of folds, we're going to draw lines to differentiate boxes. Skip two lines, draw another one here, skip two lines. I'm only going to do this so far, so make sure you're staying with me because then I'm going to change it up. Skip two lines. So let's actually pause here and start doing this. Oh, look at how uneven that is. You can make these go all the way if you want. If that's bothering you, it was kind of bothering me, but it doesn't matter. I'm going to put here, I'm just going to number these 1, 2, 3, 4, 5, 6, 7. I'm to 8 so far, so I'm going to keep skipping 2. This will give me 9 and 10. This will give me 11 and 12. Just a couple more. This will give me 13 and 14. So here we go, numbering again. 9, 10, 11, 12, 13, 14. Okay, I need one more that I'm just going to skip 2. And again, if you're using wide ruled paper, you're going to be closer to the bottom at this point than me. That's okay. You should still have space. 15, 16. Okay, now for these last few examples, this is 1 through 16 is where we're going to practice this new idea of calculating with exponents. And then the last 6 examples are review of all the rules we've learned so far. So this is going to take you back to product of powers and power of powers, a quotient of powers, and they do take a little bit more space to solve these. So for these, we're going to skip 3. 1, 2, 3, draw a line there. And then we're going to skip 3. 1, 2, 3. And again, you might be getting a lot closer to the bottom of your paper than me, but you should still have space. And if not, you have this cool thing called the backside of the paper. It's amazing. Okay, so this is 17, and this is 18, This is 19, and this is 20, and we just need 2 more. You could draw a line or not, I don't know, maybe I'll just leave it. 21 and 22 have giant boxes at the bottom. Okay, if you had more space and wanted to spread out a little more, give a little more room for those last 3, you could, but this should work just fine. Okay, you're going to go back and actually work through the cards now that you've set up your paper and given yourself space to work. I'm going to show you what it is we're doing when we say evaluating with exponents. How are we doing this mathematics with exponents? For example, the very first card says 32 times 16. Now, the fact of the matter is, I know how to type that in my calculator. I could even do it out by hand, 32 times 16. But what I'm interested in is I'm interested in looking at this in a different way, using the mathematics we've been working on for the last couple of weeks, which is exponents, powers. So when I see the number 32, what I think to myself is there a way to rewrite this number as a power of something? And it could be a power of anything, a power of 2, a power of 3, a power of 4, a power of 5. And the number 32 is pretty familiar to me. I'm going to write this so we remember where it came from. The original card says 32 times 16. I'm going to change these into powers. Notice I am writing a little bit small because I squished these first ones together. 32, and you can type this in to test this out, but 32, I immediately think of 2 to the 5th. 32 is 2 to the 5th. And 16, you might immediately think 4 squared, but what I know is I can only follow power rules, like power of a power, product of a power, things like that. I can only do product of a power. I can only work with these as powers if the bases are the same. So I don't want to do 4 squared, then I'd have a base of 2 and a base of 4, and I wouldn't be able to do anything with that. So if I got this first one to a base of 2 or a power of 2, then I need to try and get this second one also to a power of 2. And if I can, then I can use exponents to calculate these. And you can type in your calculator for a second, see if you can figure out 16 as a power of 2. Oh, if 32 is 2 to the 5th, 16 is 1 fewer than that, 2 to the 4th. Hey, look at this, 2 to the 5th times 2 to the 4th. Now I'm going to use product of powers, and I'm going to tell myself, hey, all I have to do now is add the exponents. And this answer is 2 to the 9th. Now, this is part of the reason why I don't use the word evaluate as much, even though that is what you're doing. This has a number base, so I could absolutely type in my calculator 2 to the 9th and get some big evaluated answer. But since all of this, the whole goal of this is to work with exponents, it makes perfect sense to me to leave your answer in exponential form so I can see that you really did work through it with exponents. Okay, let's try one more and make sure we get the idea, particularly if there are fractions involved. So I'm going to jump to number 4. Number 4 says 3 to the 5th times 1/3 to the 5th. I already kind of see powers of 3 here, and I want to make sure you guys understand that this technically is a power of a power problem. I'm just going to write this up on the top of my paper so that I know I can apply this to any situation, okay? If I have 1 over x to, we'll say to the 5th, really what that means is 1 to the 5th over x to the 5th, right? That's power of a power. Take a look at that again for a second. That's power of a power. That's just me multiplying the exponents, power of a power. Now, 1 to the anything is always 1. So if you have a 1 on top, that's really just a 1. And that's, oh, so that just cleans up to 1 over x to the 5th. And if I'm trying to actually work with these in exponents, now we're so used to that's how we want our answer when we're done, because we don't leave negative exponents in our answers. But if I'm going to work with it, guess what? I'm going to put it back as a negative exponent. So can you guys see how I jumped all the way from here to here? And if you can see what happened there, you probably don't need to write all of this stuff every time. Probably don't need to show yourself every time that it's 1 to the 5th. Oh yeah, that's just 1. 1 to the 5th over x to the 5th. You could jump from here all the way to here, okay? So that's what I'm going to do right here, but it doesn't have a base of x, it has a base of 3. So really this problem is 3 to the 5th times, this whole thing is going to turn into 3 to the negative 5. Okay, take a look at those steps and just replace the x with the 3, and you'll see how I got from that to that. Okay, now product of powers says I should add those exponents. 5 plus negative 5 is 0. And what is anything to the power of 0? 1. I just evaluated that whole thing with exponents. Kind of nifty, right? A different way to look at this. Okay, I actually changed my mind. I'm going to help you with one more. Let's jump all the way down to number 12. Number 12 says 1 over 64 times 8 to the 4th. Now, in any of these problems where they give you one value that's already a power, this is already a power of 8, that tells me this other number can probably be written as a power of 8. And it absolutely can. 64 is 8 squared. And this is the point where some students ask me, like, how are you figuring those out? Well, at this point, I have a lot of number sense in my brain about what the powers turn into. You guys have a calculator if you need it to help you. And if you have this hint, this one's already a power of 8. Start doing 8 squared, 8 to the 3rd, 8 to the 4th, 8 to the 5th, and you will likely see this other number. Be careful, though. It is a fraction, 1 over 8 squared times 8 to the 4th, which means this. 8 to the negative 2 times 8 to the 4th. See how I just turned that fraction back into a negative exponent? And why did I do that? Because now I can very easily add those exponents. All right, your job right now is to finish all 22 of these practice problems. Again, 1 through 16 are like this, where you are manipulating the numbers to make them powers, and you want to try to have powers of the same base so that then you can combine them as powers using all of your exponent rules. Give those a try. And then when you're finished with that, you're going to see how you did. This is a very important concept that is definitely going to come up on your test, which is happening really soon. So if you have any questions about this, anything you're confused about, message me, email me, let me know, and we'll make sure we're very clear on this.